It's my feel-good breakfast show.
Yes, it is, and a very good morning. Welcome back to the show. It's time for us to venture forth into the final frontier. And this morning, we're talking about dark matter, which is something astronomers have tried to wrap their heads around for many years. And now, an interesting discovery has been made that makes it all even more confusing. But thankfully, outreach astronomer from the South African Astronomical Observatory, Dr. Daniel Kanema, is here to explain it all to us. Always a pleasure to have you here, sir.
Thank you. Always a pleasure to be here.
So let's start at the very, very beginning of it all. Dark matter. What exactly is it?
Well, I mean, that's the thing. We don't know.
Yeah.
That's why it's dark matter. So we know what it's not. It's not gas and it's not stars. So it's not normal matter. It doesn't interact with, well, it doesn't emit light, so it doesn't give off any light, so we can't see it. But we can see its gravitational effects.
Yes.
And we know that because of these gravitational effects, it must make up about 80% of the matter in our universe. So
80%. Does it exist in forms like this? You just literally see
No.
black...
So this is like an image of merging black holes. So this doesn't actually have any dark matter in it. But in the center of in a galaxy, there's 80% of that matter normally is dark matter. We can't see it. We can count up all the stars. We can work out how fast the thing's rotating. And there's missing matter, about 80% of it. We need more in order for that thing to be working normally under gravity.
That is just so confusing. So tell us about this new discovery, how it was made, and what it all means for science and exploration.
So we're still using Hubble, which is like, I don't know, a 30-year-old instrument, and it's still making new discoveries, which is super cool. Basically looking very, very deep at a very, very faint galaxy. So it's a very big galaxy, about the same size as our Milky Way, but with about 250 times less stars.
Okay.
So fewer stars.
Yeah.
And looking at that galaxy and working out its rotation and the effects of its gravity, the scientists have worked out that it doesn't have any dark matter. So it doesn't require any dark matter in order for us to be able to solve the physics of that galaxy. So we've got a galaxy which is made up only of gas and stars. There's no dark matter in it.
And so if this was then proven 100% to be true and accurate, what would that mean for our understanding of the universe and the way in which it works and how galaxies interact?
So with dark matter, there's a school of thought where it could be our sort of misunderstanding of how gravity works. So there's something wrong with our equations that needs to be fixed. So then it would be present always.
Yeah.
Whenever you see stars and galaxies, it would always be there. The fact that it's not there in this galaxy means that our understanding of gravity seems to be correct, and dark matter can either be there or not be there. Actually, a couple of years ago in 2016, the same team discovered a galaxy with almost 100% dark matter, with very few stars.
Wow.
So now we've got these extremes. We've got galaxies with very little dark matter and a lot of dark matter, and kind of everything in between.
I'm just thinking it took me so long to drill in 10 meters per second squared acceleration into my mind right now that I've got to change that. It's going to be a disaster. But okay, that's quite fascinating stuff. And does it differ from antimatter, or is that just a...
Yeah, so antimatter is kind of the opposite of matter. It's something completely different.
We'll touch on that next time, shall we? Dan, thanks so much for joining us. We really do appreciate it. I hope that's fascinated you as much as it has me. Let us know on our Facebook page which scientific discoveries have blown your mind in this past week. And of course, when you share them with us, use #ExpressoShow.